All right, guys, welcome back. So today we are going to continue with chapter 1 and looking at matter by looking a little bit more closely at our states of matter. Okay? So our goal by the end of class today is to be able to represent and describe the three main states of matter. And thankfully, we have already talked about this and what we have learned in our previous science classes earlier this year. So just as a review, before we start looking at the states of matter, we know that matter is going to be anything and everything that has mass and occupies space. So we did a great job brainstorming some different examples of matter and basically decided that everything we can see around us is matter. We also said, looking at those examples, that not all matter behaves the same way. And we can categorize matter into three main categories. So, when we're looking at our states of matter, we're going to be looking at solids, liquids, and gases. There is a fourth state of matter called plasma, but we're going to not focus on that one as much. Okay? So we know we have these three states of matter. Okay, we might know that a desk is a solid, water is a liquid, and oxygen is a gas. So we probably know some examples of each one of these. But what we're going to look at today is what makes a solid a solid? What makes a liquid a liquid? How can we determine what state of matter a substance is? And we're going to do an investigation to look at how these particles of a solid, liquid, and gas all compare to one another. To look at the particles within a solid. So right here, we have a solid, and we can see all the particles that make up that solid. When we hit play, we are going to see that these particles kind of vibrate in place. Okay, they're not really moving too much. Okay? Some other things we should notice is the space between those particles. Do we notice, are those particles close together? Are they spread out? What do we think? Okay. Another thing we're going to want to look at is our solid here really changing shape or volume? Or are those particles pretty much staying just in one place? Okay. So those are the main things we're going to want to look at when we're observing the solid. Okay. Transfer what we saw in that simulation into our table here. So when drawing a solid, we're going to draw those particles nice and compact. Okay, so our solid particles are going to be pretty close to one another. When our particles started moving for a solid, they were moving at a very slow speed. And since they're moving at a pretty slow speed, our particles maintained the same shape. So our solids are going to have a definite shape. They're not going to spontaneously look different. So if you think about your desk is always going to be in the same shape. It's not really going to change based on its environment. Similar with volume. Your desk is always going to take up the same amount of space. So solids, in addition to having a definite shape, are also going to have a definite volume. Is a liquid. So here we have our liquid particles. So we can see that these are a little bit more spread out than when we had with our solid. So that's one difference already. Our liquid particles are going to be a little bit more spread out. When we press play, we're going to notice that these guys move a little bit faster, okay? And we're also going to notice that these two gray molecules are going to be able to move around a little bit more, okay? So our liquid particles are going to be a little bit more spread out. They're moving a little bit faster. And our particles in general have more room to move. They don't always stay in the same place. To transfer this to our table, we could draw our liquid particles a little bit further spread apart than what we had for our solid. Okay, so our liquid particles are going to have a little bit more room to move. Okay, and because they have more room to move, they're going to be able to move a little faster. So we're going to say that they move at a medium speed because they're a little bit faster than that solid. faster and they have more space to move, we are going to see that our liquids are able to change shape. So these guys have no definite shape because those particles do not have to stay in the same place. That being said, even though our particles don't stay in the same place, they have to take up the same amount of space or the same volume. So while our liquids do not have a definite shape, they are going to have a definite volume. So if you guys think about a 12-ounce can of soda, okay? No matter what you do with those 12 ounces of soda, whether you pour it into a glass, whether you pour it on the ground, you're still going to have 12 ounces of liquid. So it has that definite volume. However, that liquid or that soda does not stay in the shape of your soda can. Okay, so since we have the space between particles for them to move, our liquid is going to fill the shape of our container. So if we pour that soda into a glass, it's going to take the shape of the glass. If we pour that soda on the ground, it's going to take the shape of the ground. Okay? So for liquids, our particles are a little bit more spread apart. They're moving a little bit faster. And because of that, they're not going to have a definite shape, even though they always take up the same volume. That is a gas. So we can already see our gas particles are going to be much more spread out than our solid or liquid. We notice a big difference here. Okay, these particles are really spread out from one another. And when we press play, we are going to see that these particles are really going to be moving fast. And they're going to be moving all over the size of our container. Okay, so for our gas, we have a lot of space in between particles, which allows them to move a little faster and to really change the shape and volume that they are taking up. We can go ahead and transfer these observations into our data table. So when we're drawing a gas, we're going to draw these particles as spread out as possible. Okay, our gas particles are really going to want to spread out from one another. And because they're able to spread out so much, these guys are going to be moving the fastest. Okay, so our gases are going to have the greatest amount of speed. Okay, and because they're moving so fast and we have so much space in between them, gases are going to be able to fill whatever shape their container is. So we do not have a definite shape here. Okay. And because they're moving so fast and we have so much space between them, they're not going to have a definite volume either. They're just going to fill the entirety of their container. So whatever container our gas is in, that's going to be our volume of our gas. Okay? So we can kind of see how our properties change based on what phase we have. As we move from a solid to a liquid to a gas, our particles are moving faster, they're becoming more spread out. And as they're becoming more spread out, they're becoming more fluid. Okay, they're not as rigid and held in place. All right. So this kind of brings us to a question. What would happen if we took our solid particles and we somehow sped them up? Okay, so when we think about speed, we're really thinking about energy. So what if we took our solid particles and we gave them enough energy to really speed them up? Okay. This is going to be where we get into a phase change. So if you guys remember, a phase change, that is just a physical change. We're not changing our particles at all. Okay, we can see we have green particles throughout. We are just changing the space between them, okay, and how fast they are moving. So if we start with a solid and we are able to increase the energy and speed up those particles to a liquid, that's going to be a process we call melting. Okay? One I'm sure a lot of you are familiar with. And then if we took those particles, we're at a liquid and we heat them up even more, we add even more energy, that's going to be when we boil or vaporize and become a gas. Okay, so as we increase our energy, we're able to move between these different phases. Okay, this is a phase change. We can actually even go straight from a solid to a gas in a process called sublimation. So if we speed up the particles of our solid fast enough, we can just transform them right into a gas. On the flip side, if we took our gas particles and we slowed them down, we lowered their energy. This would be a process called condensation. Okay? There we're taking a gas and we're transforming it back into a liquid. If we continued to slow those particles down, that would be a process called freezing. And that's where we're going from a liquid to a solid. So I'm sure a lot of these words you guys are familiar with, but just keep in mind that these are all physical changes. Okay, so whenever you see one of these phase changes, we're just changing the speed of our particles and how far they're spaced out from one another. So these are all going to be physical changes. Okay. All right, those is going to be the highlights of our states of matter. Please let me know if you guys have any questions as you are working.